Welcome everyone to video number 7 in our series OpenGl ES. In this video I decided it's now time to build a small framework to ease our job in creating our 3D scenes. I was trying to delay this step as much as possible so that we have a flat file which contain all the codes or at least an example of everything that we want to include in our latest framework. But I noticed that the file is getting bigger and bigger and much of the code does not belong to a activity. So that's why I'm going now in this video to build a small framework. Basically, we will not be learning any new OpenGL functions today, but rather we will be cleaning our code and putting it to different models to enable us of building a more complex scenes hopefully in the future. I decided to keep the structure of this framework as flat as possible, so I will not be using too much inheritance, maybe 1 or 2 levels maximum. Most of the classes I will try to keep small and concentrated. As you can see here on the right hand side, I will be dividing our framework into 4 sections. So core, custom objects, UI and utils. The core will include the basic framework, so we'll have interfaces, for example, for receiving input from the user. In the future, other interfaces will be added, of course, to that for updating objects and updating the scene. Maybe we will see as when we need a new interface, I will be adding that. The basic objects in our class would be also included in this package core. So it would include a camera, a program, which represent our shaders, the vertex and fragment shader, the texture, and a vertex buffer. We will have 2 abstract classes, one called Aobj for abstract object and Ascene for abstract scene. So the object will be the class representing entities or components in our 3D scenes. For example, our rectangles that we built in the previous tutorials. Those rectangles can be derived from Aobj. Ascene will be the basic class for our scene. A scene will contain all the objects in our 3D project. As you can see here, I have put a snippet of this class Ascene. It contains, as you can see, a context. This will be used for loading resources mostly. Then we will have a list of objects. So this will be all the meshes that we will have in our scene. As I said, like the rectangles that we built last time. The programs, this will contain all the programs that we need in our scene, the textures that we need also in our scene, and a camera. So the idea here is that we will initialize an instance of this class scene, and then we will be adding objects to it as we need. And this class scene will take care of passing the input for the camera so that we can move the camera around, and to call the initialize and render for the objects so they can be initialized and rendered on the OpenGL surface. The second subpackage in our framework would be custom objects. These will be specialized objects which will be derived from this abstract class Aobj. So as you can see here, I put an example cube or sphere or maybe rectangle or any other kind of mesh which we want to draw. In the subpackage UI, I tried to isolate the classes which has to do with the Android activity. For example, we have this activity where we have 3 buttons and the OpenGL surface. So we want to get input from those buttons and draw output to this GL surface. So for that, I will be using the scene mainly for drawing and initializing the objects, and the input class will be implementing the gestures and other functions related to the input from the user. As a subpackage, util will contain different functions which will be used frequently in our application. Those functions will be mostly static functions, and as the name says, so GLUtil will contain functions related to OpenGL. MatUtil will contain functions related to matrices and vectors, and any other utils I will put it inside this class. So let's start coding. So as you can see, this is our activity class, and it got very long. It contains now everything here from checking error functions to loading assets and compiling shaders, creating programs, everything we need to initialize our vertices and also, of course, to draw them. And it also contains the input functions here. So what I'm trying to do now is to clean up this activity. So let's create the new packages and the new classes. we created an empty files to contain the classes we want to write. Let's start with the classes in the core package. I would like to start with this interface, IReceiveInput. So this would be a simple interface which will allow a component to receive input, as the name suggests, from the activity. As you can see, it includes two functions. So each class implements this interface, has to provide an implementation for these two functions, and they are scroll and reset camera. So this is meant to be used mainly, as you can see, in the camera class. The scroll function will pass the distance on the X and Y axis from the activity, and this mode will contain our input mode. Is it moving or rotating, or is it up or down for now? Let me create this enum. So as you can see, it's an enum which contain move, rotate, up or down. Let's correct this function here. It should take as input this enum, and that's it. So let's start taking these functions out from our activity. So as you can see here, we have the functions related to creating the program. So read asset file, compile shader, and create a program. Those functions I want to put inside the program class. So let me show you how the program class will end up to be. So I already wrote this program class. I like this imports actually to be only one import like this. And let's go through this class. So as you can see, we start by defining a tag. This will be used only for debugging purposes. Then we have the ID of the program. This would be the handle of the program in OpenGL, and we will have two other handles for the vertex shader and the fragment shader. I will also save the code of the vertex shader and the fragment shader, and that's it. So I decided to allow access for creating this program class only through this static function load. That's why you can see here that I made the constructor private. Basically, this function just create a new program and call the function create program, passing to it the context, so for loading the asset files, and the name of the program, and then it returns this program. So the function create program will call the functions compile shaders, passing again the context, the name, and the type of the shader. It's still as before, as you can see here. So the compile shader will look at the type of the shader and then use the utilities to read the asset files. So if it's a vertex shader, it will add the suffix .vert. If it's a fragment shader, it will add the suffix .frag, and this function read asset file will read this file. I will go through this function later. And then we create the shader and put the source and compile the shader as done before. And of course, we always look if there's an error in the compiling process. So that's it. Now we created our vertex and fragment shader. We create then the program, then attach the shaders to this program. This MID would be the handle of the program, as I said. And we check the error once here. And then we also check an error during the link of the program. And that's it. Basically, now our program is created and the static function will return it. One thing I wanted to focus more here is that the static import allows us to call the OpenGL function inside this package, OpenGl ES. And actually, I want it to be here 3.2 without us writing every time GLES 3.2 point something for. So for example, as you've seen here, all these functions, GL shader source, GL compile shader, usually we used to write them as GLES 32 point create shader and so on. But using this import static, then we can remove the package name and it still work. And what I like by this is that if you want to go to a lower OpenGL version, you only need to change that here. So that's our program class. Don't forget this function read asset file need also to be created in the utils, but I will talk about it when I go to the util file. Let me go to the main activity. So basically those are these three functions here. So actually we can get rid of those now. And let me go now to this class utils and paste the code for that class. So this is the class utils. For now it contains these constants which we defined earlier. So how many bytes per float, bytes per short, and so on. And of course our read asset file, it's a copy paste from the previous function. So as you can see, it used this context and you create a buffer reader about the file name which we passed here, and then it read it line by line and return the result. This function read bitmap resource does the same. It uses the resource ID of the bitmap and the context to create options, and then using this class bitmap factory to decode the bitmap and return that. So now we finished the class Utils, class IReceiveInput, and program. There should be no problems now. There's this check error which is in the class GlUtils. So let me then jump to this class GlUtils, and it actually contains for now only this function. And as before, I want to change this to GLES32. As you can see here, we can now call this function glGetError directly. That's it for this class GlUtil. Now let me check the program class. Now it should be finished. Now the texture class. So again, as before, I want to first correct these imports, and then let's go through the class. As you can see, it only actually have one member variable, which is the ID of the texture. So the handle that OpenGL has for this texture. And again, the constructor will be private, and new instances of this class will be created using the function load, where we pass the context and the ID of the texture. So the ID of the bitmap which we want to load. And again, this class will just create the texture, call this function send texture to GL, which we wrote in earlier tutorial, and then it should actually return this texture. It also has this function bind to bind the texture, and of course the send texture to OpenGL. So this function will create the handle for the texture, save it in this ID member variable, and then call this util function to load the bitmap, then bind the texture, set the parameter to nearest, I'm filtering to the nearest, and then copy the bitmap to the OpenGL buffer, and then create the bitmap and free the memory used by the bitmap, since now it's on the OpenGL side. It seems there's no problems in this class. Now, as you can see, we can remove these two functions from our main activity. So the send texture to GL and check error function. Let's now get to these input functions. That means let's go to the input class. This input class will implement the onTouch listener and the onGesture listener. So let me paste the code of this class. So as I said, implements the two interfaces, and it keep index to 4 image buttons. So one of them would be the move button, the rotate button, the up and down, and the reset camera button. My goal here was to minimize the code in this main activity. So I choose to put most of the code related to these buttons inside this class called input. And as I said, I kept it out of the core package since it's related to the UI, and based on your design, maybe you don't want to put these buttons here and just add more code inside this main function. Let me go through the way I decided to implement this class. So as you can see, now I have the gesture detector as before. This was in our main activity, and then we need the input mode, which will default to move, and this class will keep a list of IReceiveInput. So this is a list of the classes which want to get the current input, and it will call all of them when we click. So currently will be only one camera, and only this camera will receive this input. When I did this, I was thinking that maybe we want also some other objects to get other kind of input. Maybe in the future you want to have another button, and you want to click on that button to be passed to an object to start rotating or stop rotating or do any other kind of input, and that's why I put this here. But the constructor of this class receives the context and these 4 image buttons, and then it saves them in the member variables, and of course set the onClick functions to set current input mode, and this function is copied directly from our main activity. So this would be the same function as here in the main activity. Let's go to this function. As you can see here, it just changed the current mode and the background color of the button based on the current selected input mode. And of course, when the reset button is clicked, then it calls on reset camera, and this will go to the input receiver again and call this function called reset camera. Then the gesture detector is created, and the listener is set to this, since this is this class implements the onGesture listener. And then in the onScroll function, we call this function onScroll, where it loops through the input receivers and call for each one of them the scroll function while passing the current input mode, the distance x and y. So this is all for the input class, and as you can see, it seems there is no problem there. Let's look to our object class. As I said, this class will be abstract. Let me copy the code of this class. The purpose of this class is to hold a 3D object in our scene. And for each object, we will be keeping a model matrix. This matrix tells how our object is positioned in the 3D scene, and it will have a reference to the whole scene. This reference will be passed in the function init, as you can see here. This class has 4 abstract member functions, which every derived class should implement. So the first one called onInit. This function is called from inside the function init. You will see that this function init will be called from the scene init function. So when our OpenGl surface is created, there is this function called onSurfaceCreate, and inside that function the whole scene should be inited. And when the scene is inited, then it will call the init function for each object in the scene. This will give our object here the chance to initialize its buffer, program, and texture, everything it's needed to render itself. We will also have a function called destroy. This function should be called when we want to remove this object from the scene. I will keep it empty, and I will not worry now about removing the objects from the scene, although that should be a problem if you have too many objects on your project and you want to load and unload objects from your scene. Then there is this function called update. The main purpose of this function is to give the object the chance to update its coordinate or its even shape. So imagine that you have a cube and you want this cube to be rotated, then this would be the place to rotate this cube. And this function, as you can see, it will take the current timestamp as an input. The last abstract function here is the draw function, and of course here the object should be rendered. And this function will be called from inside the render function in the scene, and it will pass the view matrix and the projection matrix which are needed to render the object. So as you can see here in the constructor of the object, we only create this model matrix and initialize it to identity matrix. I will take care of this MatUtils class next. I also decided to include 2 functions here called translate and rotate, as the name suggests. So the first one would shift our object inside the scene, while the second one would rotate this object. And there is this protected function to draw the triangle. This function mainly called the OpenGl draw array function, and I'm assuming that we will always be drawing triangles. And this would be the first one, mostly would be passing it as 0 and the count of the vertices we want to draw. Yeah, that's it for this class abstract object. Let me now take care of this MatUtils. So as you can see, the class MatUtil contain only static functions. So the first one sets a matrix to identity. This implementation assumes that the matrix is 4 by 4, and then we have this scale matrix column. So we pass a matrix here, and the index of the column we want to scale, also the number of columns in the matrix and the scaling factor. And basically this function and this function will loop over this column and multiply its elements with this scaling factor. Then we also have this shift matrix column, which does the same, but instead of multiplication, it adds a certain offset to the element of the column. And we have this function copy matrix column, which take an input matrix and an output matrix. It takes the index of the input matrix, which we want to copy from, and the index of the destination matrix. This is the column which we want to copy to, and of course the number of the columns in the source matrix and the number of the columns in the destination matrix, and it just copy one column to the other one. Finally, we have this function translate matrix, which would take a 4 by 4 matrix and an XYZ vector, and will add a translation corresponding to this XYZ vector to this matrix. And that's it for this MatUtil class. Now if we went to our abstract object class, as you can see, there is no problem here. I mean, there is this problem with OilerM, but I will solve it later in a later tutorial. I will be using another function here. There is no problem in this class, as you can see. Let us take care now of the VertexBuffer class. So the VertexBuffer class will represent our OpenGl VertexBuffer. So as you can see, it will contain an ID of the vertex array object and an ID of the buffer. On the creation of this class, as you can see, we generate the ID, the vertex array, and then also the ID of the buffer. And then we have this function load. And in this function load, as we done before, so we create this native buffer and we fill the vertices, which are pass through this parameter data, and then we bind our vertex array, we bind the buffer, and we copy the data to the buffer. And if this input static draw is true, then we pass the static draw, otherwise it should be a dynamic draw. And there is this function bind here, which will bind our vertex array. And that's all for this vertex buffer. So now we can take care of the scene. As I said in the introduction, this class will keep track of the context for loading text and image resources, and it also have a list of the objects we'll be using, and also the programs and the texture which we need to render our 3D scene. Let me refactor this to textures. I decided to have these programs and texture as a hash map, and assuming that the name of the program should be unique, so I don't load the program or the texture twice. You will see the mechanism I used for that later. And finally, this class keeps track also of the camera. The constructor is simple, just take the context. Also, we have the getWidth functions. We have an addObject function, just to add an abstract object to our scene. Then we have the initObject function, which will loop through the objects and call the function init on them while passing this abstract scene to the initted objects. Same for the update objects. We will get the current timestamp and pass it to the objects in the scene. In draw objects, again the same. We loop through the object and we call the draw functions for each one of them while passing this view matrix and projection matrix of the camera. I will take care of those functions under the camera class next. So loading programs and texture, as you can see, is also taken care of inside this class, and they are done in the same way. So for the program, for example, we pass the name of the program. We look if we have this program name in our hash map. If it's already created, then we return that. Else, we load this program and add it to the hash map and then return it. Same for the texture, but this is done now for the ID. So look if it's already there. If not, then create a new one, save it, and return. So that's all for this class Ascene. Let's go to the camera class. As you can see, this class implements the IReceiveInput. That means it should have these two functions, scroll and reset camera. The camera keeps tracks of the view and the projection matrix. And for that, I'm using the same mechanism as before. So I keep the position of the camera and the rotation angles X and Y. I will also be keeping a reference to the abstract scene. This will be passed also again from the init function of the camera. So the constructor of the camera is straightforward. We just create this view and projection matrix. We set them to the identity, and then we translate the view matrix on the z-axis as we done before. The init, we just save the abstract scene. The destroy is not implemented, as I said before. The update function of the camera is different than the update functions of the objects, since as you can see, the camera does not extend the abstract object class. And actually, this function will be called when the surface changed. And that's done so that we can set the viewport using the new width and height of the GL surface, as we done before in our main activity. So that's the update function. The scroll function is the same also as before. We check the current mode, and if it's move, we change the position of the camera. Also, if it's up, we change the Y position, and if it's rotate, we change the angles. Then we update the view matrix. On the reset camera, as before, we reset the position and the angles, and then we update the view matrix accordingly. And of course, we have two getters, one for the projection matrix and one for the view matrix, so that we can use them inside the abstract scene or any other place. So that's it. It seems now there is no problems in the scene object and also not in the camera object. We already now finished all the classes here inside the core. So inside the UI, we already did the input class. Let's go to the scene class. Let me first make this import as before. As you can see, the scene class extends the abstract scene and implement the renderer class. That means it should implement these three functions on surface created, on surface changed, and on draw frame. Let's go through this class. So as I said, I used this class to not mix the input and GUI stuff with the core classes. So here we have the input and the surface and the activity. This class will also keep track of the label we put in the upper right side of our activity, that's where we were displaying our frames per second, as you can see here. So in the constructor, all the GUI components should be passed to this class. As you can see, the activity, the surface view, the image buttons, and this text view. This class will keep track of the activity, the surface, and the text view while it passes the images to the input class. Then it adds the camera as an input receiver. Remember, this camera is defined in the parent class abstract scene. So now that the input will be passed from this input class to the camera, and then it sets the GL version to 3, and it set the renderer to this, since we implemented the GL service view renderer interface here, and the touch listener to the input class. The implementation of the onSurface created is straightforward. So we set the clear color, then we init the camera, then we init all other objects. So this function is implemented in the abstract scene. On the onSurface changed, we update the width and height and then call the update camera to set up the viewport. On the onDraw frame function, we update the frames per second as before. Then we check the error once, as we were doing in our main activity, then clear the GL buffers, then we update the objects. So update the objects, remember that here we pass the timestamp for each object. So if an animation being done by any of the objects, this is the chance for the object to update its position or its shape. And finally, we have the draw objects, where we loop through the objects and draw them. And that's it for our scene class. So now if we went to our main activity, you can see that we implemented everything here. Let me remove these member variables. So the camera position and the camera angle reset function, all this has been taken care of in the input class and in the camera class. Also the onSurface created, send data to GL, surface changed, all this has been taken care of. Update also update frames per second, draw frames, also we don't need that. All the input functions, all this is not needed anymore. Of course, now we want to remove this implements. Also this enum, the gesture detector now is also in the input class, we don't need it here. Those constants we implemented inside the utils. We will keep now the vertices for now. We will keep these vertices for now. We need also to remove this here. And now let's start building our scene using our small framework here. The first thing we want to do here is to define a scene object. Let's call it mScene. Let me look at the imports and correct them also. So as you can see now, it's neat. We don't have too many imports. Now we need to construct our scene object. We pass for the constructor the activity and the GL service view, the 4 buttons, and the text view. Next thing we want to do is to add some objects to our scene. For now, we don't have any class implementing any objects. We only have this abstract object, but since it's an abstract class, we cannot create an instance of that. So we need to write our first object here. I decided to call it PObj. The P here stands for position, since the buffer of this object will contain only the X, Y, and Z coordinates. So as you can see, I put that here in the comment. So for drawing an object, we will need a program, a vertex buffer, and vertices. The program will contain our shaders. The vertices is a reference to the Java array containing the vertices, while the vertex buffer is the OpenGl representation of these vertices. So actually, these vertices here could be redundant unless you need them on the CPU side in the update function later if you want to update some vertices of this object. So since this object will contain only positions, I decided to have a uniform color as we did in our second tutorial, and this member variable in vertices will contain the number of vertices in this object. So in the constructor, we pass an array containing the X, Y, Z position of the vertices and the red, green, and blue color coordinates. We save those and we set the number of vertices to be the number of floats in this array vertices divided by floats per position. So by 3 basically. The onInit function will be called, as you've seen in the onInit surface on surface created. Here we want to load our program. I will be using the model view projection program, which we created in an earlier tutorial. This was a simple program, as you can see here. It contains an attribute which is a position and 4 uniforms, 1 for the color, and the 3 matrices, model view and projection. and the program just set the GL position as before and output the color for the fragment shader, and in the fragment shader it just set the fragment color to this color, and that's it. The next step is to create the vertex buffer and then load the vertices to it, and we are setting the static draw to true since we will not be changing now this object. Then we use the program and set our attribute. Then we call the program.use, which will just call the GL function use program, and we then call the set attribute, and this function will get the location of the attribute first, it then enable it, and then set up this attribute with the given length, stride, and offset. So that's for the init. Now we have our program loaded and the vertices on the OpenGL side. The destroy function, as I said before, it's not taken care of yet. The update function will do nothing since we will not be doing any animation for this object. And in the draw function, as before, we want to first to use the program, bind the array buffer, then set the uniforms for the color, as you can see here. So set uniform, it just get the uniform location, then it set it to the values which are passed here. Similarly for set uniform for matrices. Yeah, so we set the color, then we set the 3 matrices, and finally call the draw triangles of the Aobj, which call the GL draw arrays triangles and passing the count and first. So that's it for our PObj. We can use that now in our activity. We simply need to call add object to the scene, where here we are creating an instance of this object. Let me see which vertices I will be passing for this object. All our vertices here has position, color, and texture. Let me remove the color and texture and use this in vertex data. Let me also put this in 2 lines. So first we create the object, position object, let's call it PO, and then add it to the scene. And let us run the program. So as you can see, we have our rectangle drawn here, and we have the buttons, and the click handle works fine. So we can now move towards the objects or away from the objects, also to the right and the left, also up and down, and also rotate our camera. FPS output is also working. So our framework is working. As you can see here now, creating an object is easy. So we only need to create a scene and then start adding objects to this scene. So now adding a second object, for example, is simple. We can just create a second object and pass it to the scene. But let's clean the vertices for this object also, since we only have positions implemented now. So now let's rerun. And as you can see, we already now have 2 rectangles. In the next tutorial, we will be implementing more complex objects. However, adding them to the scene will be as simple as we did for these 2 objects here. Thanks a lot for watching, and see you in the next video. Bye.